Today we'll start up with the new concept, the loops. For repetition of any step in a program at the time of execution, we require loops. When you want to repeat something again and again for some number of times, we'll go for loops. The loops are classified into three types, which are the first one, for loop. For syntax goes in this way: for initialization, a colon, condition, one more colon, and increment or decrement. In a set of braces, write the set of instructions. For example, we say for is a keyword. Actually, at the beginning we say initialization and a condition and increment or decrement. This is what is required as the for loop. And the entire codes, what all you want to write, the code will be given over here. We'll take up a small example. The example goes in this way: hash include stdio.h, a main function, and an integer variable I, and a for loop. I said initialization, let I begin with 1, I less than, condition I less than or equal to 10, I plus plus. Now when I say printf k along with a new line character, execute the program, you'll be getting k for 10 times. 3, 4, 5, 6, 7, 8, 9 and 10 times, because you have repeated your loop for 10 times beginning from I and 1 less than or equal to 10. Likewise, you'll increment I up to 10 when it is 10 less than or at least is equal to 10, and so you'll print it. After that, because the condition is false, you'll be out of the loop. Now in case of printing k, if you print %d, which is for I, you'll be printing all the values from 1 to 10. So in this way, you can repeat particular code for certain amount of time. We'll take up a small program on for loop. This is a program which prints the sum of n natural numbers. I need a limit given by user and also the variable I, and to take up the sum, which initially is 0. I'll say the user printf enter a limit, new line character, and I'll say scanf %d comma ampersand li. Now the limit will be decided by the user. For I equal to 1, I less than or equal to limit I plus plus. In this I can say sum equal to sum plus I. So it's basically it's 0 plus 1, 0 plus 1 into sum. Likewise 1 plus 2, 3 into sum, 3 plus 3, 6 into sum, 6 plus 4, 10 into sum. Likewise I will be incrementing the value of I. After getting the sum of 10 natural numbers, say printf %d comma sum. So this gives the output, enter a limit. Now the compiler is expecting me to enter a particular limit. If the limit is 10, the sum of 10 natural numbers is displayed, which is 55. So 10 as the input, 55 is displayed. Now if I give 5 as my input, so sum of first 5 natural numbers, 1 plus 2 plus 3 plus 4 plus 5 is 15. So this is a program with which you can get the sum of n natural numbers. Now considering a printing statement like this: 1 plus 2 plus 3 plus 4 plus 5 equal to 15. I need to print such an output. For that, what I need to say is, if I is less than li, then printf %d plus comma I. If it not, else printf %d comma I again. Now here you need to say equal to. Now check out the program. If your input is 10, it will be 1 plus 2 plus 3 plus 4 plus 5 and so on up to 10 equal to 55. If your input happens to be 15, it will be 1 plus 2 plus and so on up to 15 equal to 120. So this is the program with which you can get the sum of n natural numbers. Now modifying the same program to getting the factorial, for that we need to start with 1 and let the variable be fact. We cannot say 0 because factorial is nothing but multiplication and it says 0 into anything gives 0. So start it with 1. So the program is hash include stdio.h, a main function in which I say the number and f fact which takes 1 and a variable so that I can repeat the loop. Now printf number or new line character and say scanf %d comma ampersand n. So the value what I give is given into n. Now for loop for I equal to 1, I less than or equal to 5, I plus plus, let it be the value given by n. Now inside this, when I say fact equal to fact into I, finally I will be getting the value into fact. So printf %d comma fact. So if my input is 2, it's 2 obviously because the factorial of 2 is 2. If my input is 3, 3 into 2 into 1 which is 6. If my input is 4, 24 is the factorial of 4, and if my input is 5, 5 factorial is 120. So here I'll be multiplying 5 into 4 into 3 into 1 or 1 into 2 into 3 into 4 into 5 which gets the factorial, placing into it. Now if I say in the previous program, if I less than the given limit or let it be n, I can print %d into equal to comma I. If it's not, go to else block and say printf %d comma I, and here we need to say equal to. So if my input is 5, it will be 1 into 2 into 3 into 4 into 5 equal to 120. Usually we don't write factorial as 1 into 2 into 3 into 4 into 5, but we write 5 into 4 into 3 into 1. So here instead of making it, starting it from 1, start it from the value given by user, and it should be greater than or equal to 1, and also its decrementation I minus minus. Now you will say fact as 1, 5 into fact 1, 5, and here the condition should be greater than 5. So we'll be saying 5 into 1, 5, and here 5 greater than should be 0. 5 greater than 0, yes, you'll say 5 into. Likewise, you'll decrement. So 4 into. At the end, when it is 1, you'll display 1. So if your input is 5 now, it will be 5 into 4 into 3 into 2 into 1 into, we need to eradicate the into symbol, and that is possible by saying greater than 1. Now if you say 5 as your input, it is 5 into 4 into 3 into 1 equal to 120. So this program gives you a factorial thing for any given number. 6 into 5 into 4 into 3 into 1 equal to 720. So by using a for loop, we can go for either finding the sum of n natural numbers or either finding the factorial of a given number. The next loop is while loop. A while loop is also the same, if you want to repeat something again and again, go for using the while loop. Initialization at the beginning and the while in that a condition and set of braces where we need to write increment and decrement and a set of braces. We'll take up one more example. First of all, we'll print the numbers int I equal to 1, and this is initialization, the condition while I less than or equal to 10, and write the set of statements which is printf %d, a new line character, comma I, and then finally the last one, incrementation. Execute it, you will be getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as your output. If you begin it with 10 and if you say less than, greater than or equal to 1 and also decrementation, you will be getting 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 as the reverse output. So either of the ways, either you can increment, you can decrement a while loop. We'll take up a small example. Now it happens to be, we'll print up a table of a given number. So integer the number so that I can print its table and also the limit up to where we want to go. So say printf enter number and limit, a new line character. So scanf %d and %d comma ampersand number comma ampersand limit. So here we'll get the numbers from the keyboard and one more variable so that I can repeat the loop. For I equal to 1, I less than or equal to limit I plus plus. In this I can say printf %d into %d equal to %d, a new line character, comma I comma the number comma I comma n into I. So we'll be printing the numbers. I need 8 table up to 13. I equal to 1, I less than or equal to limit I plus plus. The same thing can be done by using a loop as well. So here we'll be printing the table, given table, let it be 8 and limit be 13. So it says 1 into 8, 16, 8 to the 1 into 8, 8, 8 to 16 and so on up to 8 into 13 equal to 104. So this is by using a for loop. We can use the same thing by using a while loop as well. Initialization I equal to 1 and while I less than or equal to limit, and inside the block printf %d into %d equal to %d, a new line character, comma the number comma I comma n into I, and say I plus plus. Again it gives the same thing, let the number be 9 and this time my limit be 20. So it says 1 to 9 ones are to 9 20s are. So this way we can give up to all the required numbers, tables as well. We'll go for another program now in which we can get the Armstrong to check whether the given number is Armstrong or not. Armstrong number, a mathematical number. Before that we can go for printing the reverse of a number. I'll take up a number from the user, printf enter number, new line character, and scanf %d comma ampersand into n. So the value is on the screen. Now what I'll do is I'll be dividing the number for, we'll check for the condition later on. printf the last digit. Consider if the input is 5759338, the number should be 8395, the reverse of it. So first of all, I need to print 8. So that particular value, which is possible by dividing n with 10. The remainder will be 8 is displayed on the screen. Now I say n equal to n slash 10. So it gives the coefficient which is 589. So this should happen up to certain number of times, that is until n is not 0. If it is 0, it will come out of the loop. So if the value, consider the value be 5938, so it should be 8395. This is how you can make a number reverse of it. We'll give up any number even if it is for more than 5 numbers, 1, 2, 3, 4, 5. The output should be 5, 4, 3, 2, 1. Now we'll go for taking up an Armstrong number. A number and one more variable a. So scanf %d comma ampersand number. We got the number. Now I'll divide the number for the same condition n. Printf %d. We are not supposed to print it, but we are supposed to get the remainder, which is, let us consider the variable r for remainder, in which I'll place the remainder of n percentile 10. If the number is 153, we'll get 3 into r. So I say sum another variable with which sum plus r into r, and I say n equal to n slash 10. Now finally I say if a equal to sum, I'll be printing %d is an Armstrong. If it's not, say else and say printf %d is not Armstrong, and here a small change. After getting the value, place it in a. We are saving the value. Now if the value is, define the variable sum comma sum which starts from 0. Now if the value given by user is 153 is an Armstrong number, that is what a holds and also what 8 holds. So consider the value be 153. 153 is an Armstrong number, and give one more value, say it may be 456, which is not an Armstrong number. An Armstrong number is a number in which if you divide each and every digit and cube it, so 3 cube is 9, 27, and 5 cube is 125, and 1 cube is 1. If you add all these, you will be back again to 153. So such a number is called as Armstrong number. I repeat, get the digit individually and cube it. 3 cube 27, 5 cube 125, 1 cube 1, and add all these cubes, you will be getting back to the same number. Do for any other number, you won't get the same number unless it is not 153. And this program displays whether the given number is Armstrong or not. 789 is not an Armstrong number. And also 153 is an Armstrong number. So this program gives you whether the given number by the user is Armstrong or not. We'll go for one more proof. Use the same program by using while loop. The change is while, and initialization happens over here. So there are slight differences between for loop and while loop. It's the syntax and nothing else, not an Armstrong number. The basic, if you follow the three main concepts, initialization, incrementation or decrementation and condition, which are most commonly used for any loop. Now the final loop for today's section is the do while loop. We'll go for a do while loop program now. The same thing, hash include stdio.h void main and say integer I which starts from 1 and do all those statements, that is printing %d, a new line character that is for I. Do this statement while the condition, that is I should be less than or equal to 10 and a semicolon. So it prints all the values. So it's I++ and it should be less than or equal to 10. Now execute the program. You will be getting the values from 1 to 10. In this, first it will execute the do statements. What all it holds, it will execute the do statements, and later on it will check the while condition. Almost the same, but holds a little bit difference in its syntax as well as its nature. We'll go for a small example. We'll find out the GCD of two given numbers. Hash include stdio.h void main. I need a big number and a small number to find out the GCD. Scanf %d comma ampersand a b comma ampersand s. Now the thing is, I need to do certain statements, which is get the reminder, that is r comma r takes up the percentile between b and s. Printf GCD is %d comma r, and check, before printing it, check if r is equal to 0, do this and put a break statement. Later on, modify the values by placing the reminder into s. That is, we'll be placing the reminder into, we'll make it as the co-dividend now. So b takes the value of r, and also into s will be placing r, and into b will be placing s. So placing s into b and r into s. Now put the while condition while r end of main. When you execute the program, if the values are 17 and 2, the GCD is obviously 1. If the values are 15 and 3, the GCD is 3. So in this way we can use the do while as well.